Hi everyone, I'm SaiKiran. I'm an integration developer at Tech Hub Software Solutions. Today we are going to discuss about MuleSoft CloudHub. CloudHub is an iPaaS where we can deploy cross-cloud integration applications in the cloud. We can create new applications or we can create APIs on top of the existing applications and data sources to integrate with the on-premise or cloud or hybrid applications. So CloudHub is a fully maintained and managed by the MuleSoft itself. So CloudHub licenses will be taken by vCore and Workers, and we can also automate our deployments with the help of CloudHub APIs. So CloudHub is a highly available runtime engine which is offered by the MuleSoft. Coming to the architecture of this CloudHub, we can see that we will control the applications from the control plane, and that control plane consists an API manager and runtime manager. So from the API manager, we can deploy the applications. We can auto discover the runtime applications, and to the runtime manager, we will deploy our actual API implementations. From there, that will deploy to the runtime plane. So from the control plane, we will send the requests to the runtime plane. So the runtime plane will consist shared load balancer, and DLB means a dedicated load balancer. So for a CloudHub, by default, it will have a shared load balancer. The shared load balancer is free of cost, and MuleSoft will maintain and manage that. So in the shared load balancer, this will distribute the load across the multiple applications. So in the CloudHub, so each Mule application is deployed to a separate EC2 instance in Amazon. So our entire MuleSoft CloudHub is hosted in AWS. So here we can see each EC2 instance will consist of one Mule applications. If we have any Mule application got crashed, this EC2 instance will get restarted. So if we are updating the existing applications, so CloudHub will create one more EC2 instance, and it will create the application, the new updated application over there. It will deploy the new updated application, and it will discard the previous application from there. So this new application will be added to the shared load balancer. From there onwards, it will start executing the requests. When it comes to a dedicated load balancer, we need to configure the dedicated load balancer. For that, we may need a DevOps expertise also. When it comes to shared load balancer, we will have a rate limiting, and we will have more secure policies which are given by the MuleSoft itself. If we want more policies based on our business rules conditions, we need to configure our dedicated load balancer. So this is for when CloudHub also chooses different availability zones based on the regions. So this will not be a long distance apart, that in maximum 350 miles. So in those region only, it will deploy the applications. So coming to the vCores and workers, a vCore is a computational power to execute a Mule application. So vCore sizes may be coming from 0.1 vCore to the maximum 16 vCores. So worker is instance of a vCore. So we can say if we have multiple workers, in a sense, we will use multiple vCores separately. So minimum worker memory can have 1 GB to maximum of 64 GB, and a heap memory of 500 MB to 32 GB, and a disk storage space of 8 GB to a maximum 328 GB. To deploy an application for a high availability, we will use one worker with two workers with one vCores. I mean 0.1 vCores we will use, and we will deploy with the two workers. So each worker will be deployed in a different availability zones. So if one vCore got down or one worker got down, the other worker will take care of the executions. So by this way, CloudHub will provide you the high availability. So here there is one more functionality we need to think of is the scalability. So there are two different kinds of scalability here. To increase the computational power, we will increase the number of vCores we have. So for example, our application has more frequent requests within an hour, like 1 lakh, 2 lakh records within an hour or more than that, or even we have more, it will take more time to process the request. Then we will increase the vCore sizes from 0.1 to 2 or 3 like that. But our workers, we need a high availability, like there will be an outage situation. We should not uh, miss each and every request. Then we will increase the horizontal scaling. That is, we will add more workers of the same size. For example, we will add 0.1 vCores of multiple instances, means multiple workers. So multiple workers are combined and they will be deployed with each and different availability zones. So if one data center got any outage issue, then other data center will be taken care of the executions of that request. This is how a MuleSoft will take care of these vCores and workers. So advantages are high availability. MuleSoft CloudHub workers are deployed to different availability zones. So if one data center got any outage issue, the other data center will take care of, the other worker will take care of the application executions. So if it is completely maintained and managed by MuleSoft, we don't need to worry about the update patches and security patches. As we discussed the scalability, we have horizontal scaling for adding additional workers and vertical scaling for the vCores. And we do have this automated deployments with the help of CloudHub APIs. And CloudHub also offers static IPs. We can use these monitoring features of the CloudHub to see which application uses how much computational power and how many requests are processed by each application. And we can also see with the help of API manager, the requests and the number of requests and responses. So CloudHub offers a free shared load balancer, which will distribute the load across the different workers and vCores. But when it comes to the shared load balancer, we have a rate limiting policy. So CloudHub will decide, I mean, MuleSoft will decide the rate limiting over that, depends upon the region. But if we want to avoid that implications, we can go for a dedicated load balancer. And for persistent queues are also available within the CloudHub to avoid the outage of message loss and data loss. So coming to the disadvantages, because of this this CloudHub is maintained and managed by the MuleSoft, it is very expensive to bear. And coming to this load balancer, dedicated load balancer and automated deployments, we need to use the DevOps expertise for that. And CloudHub also offers virtual private clouds for secure deployments and secure executions. For that, we can make use of DevOps expertise to establish that. So coming to the high availability, we have 4 different use cases. Depends upon the availability of the application as well as a data loss. So in the first use case, persistent queues are disabled and we will use 2 or more workers. So in this, if we don't use the persistent queues, means there will be no latency in the message. But if one worker got down during the execution or one data center got any outage issues, the other worker will take care of the execution, but there will be a message lost during the previous execution. Coming to the second one, persistent queues are enabled, but we will use only one worker. So here we don't need to pay for multiple workers, and the performance may be impacted due to the latency of the queues to send and retrieve messages. But if the worker got down, we will face some outage issues on the application end, but we do not lose any messages because the messages are stored within the queues and they are persisted. When the application or the worker got up online, we can resume our execution from there. So in the third use case, we can see persistent queues enabled and two or more workers are used. Here we have high availability, like the data will be stored in the persistence queues. If one worker got any outage issue, the other will take care of the execution, and we will also not lost any messages because the messages are stored in the persistent queues. So we can see that our app is running without any outage at all. So this kind of application may need more licensing, and it needs they need to bear some latency during the executions. Coming to the last use case, where we will not use any persistent queues and we will only you go for one worker. So here like it is very cheap because we are using only one worker, and the application executions also will take place without any latency. For this, if the worker got any outage, then we will not see the persistent queues, and persistent queues are also not available over there. So our messages may lost in between. This is recommended for during the testing purpose, but this is not recommended in production servers. So that is all about a CloudHub. Thank you for watching. Please do subscribe for more content like this.